afternoon. This is A-musa by name. Welcome to my A-musa data solution channel. In this today's screencast, I'm going to show you how I use R programming language to do a statistical analysis. In this today's tutorial, we are going to look at descriptive statistic as well as logistic regression analysis model. Currently where I am, this is a environment where I code my variables as well as the analysis take place. Before going into the code, let me take you to the environment so you can have understanding of how this analysis is been taking place. So let me zoom on my PC so you can see how this is the output of the analysis performed in the code editor. As you can see, the title starts with data analytics and visualization using R. So for the purpose of this tutorial, I use a inbuilt data set that comes in RStudio in one of the packages called Introduction to Statistical Learning in R. Before you do your analysis, always you have to define your objective as well as you have to define your hypothesis. So for the purpose of this tutorial today, as I say, I use an inbuilt data set that comes with R, that come in the R packages. One of the packages called Introduction to Statistical Learning in R. My hypothesis, these are the list of hypotheses I'm going to look at it through. The first one is a null hypothesis and the second one is alternative hypothesis. For the null hypothesis, I want to see if there is not any significant differences between the information officers and industrial workers in terms of their salary earning per month. So while the alternative hypothesis is saying that there is a significant differences between the salary earning among the information officers, information technologies officers, and the industrial workers. So how am I going to know this? Is through the statistical analysis. How am I going to look at, should I reject this alternative or I should accept null hypothesis? Is choosing using the output generated from the analysis. Another hypothesis defined is I want to see for the multiple variables, that is salary is my target variable, but I want to compare it with education, race, and job class to predict which factors, which categorical variable has influence on the salary of employee. So before I dive in, I would like to show you a diagram for the variables that I have interest in exploring. This is a model described for using R diagram package. As you can see, I have my defined variable, which is salary of employee, as well as I have my independent variable, which starts with job class, age, education, race, and marital status. Below is the descriptive statistic illustrating the proportion of educational background of the employees in the organizations. We have a high grade school, we have some college, we have college graduate, we have advanced degree, as well as we have their ages and the health status of that particular individual working in an industry in that organizations. The other one is socio-economic factors. If I click on, you can see it. The other proportion of which comprises the wages, that is the salary earning, as well as the industrial, that is job class. Job class has two categories. That is one, industrial individual, that is people that work in industry, as well as the other category is individual that work in ICT department. As well as I have race, that is in terms of ethnicity, we have a black, we have white, we have Asian, and others. So this is a summary descriptive statistics illustrate as well as the locations of this particular employee. You can see the table below illustrate the proportion of individual in terms of their locations. So the next table is, you can see the year of services. So this is just a summary of descriptive statistics of the above variable as illustrated in the diagram. So now let me start looking at the linear regression analysis. For the linear regression analysis, you can see, as I say it in my hypothesis, that I'm looking at among the individual work in industry in an organization, which one earn more significantly compared to the others. So remember, for the job class, as I mentioned, that I have individual working in an industry as well as individual working as an IT officer, that is information and communication technologies officer. So this table is illustrated that I have two variables. The one is a reference category. For the reference category, that is the information, people that are working in industry, while the explanatory variable, I'm looking at the information technologies officer. So from this table, as you can see, I have a coefficient, I have a 95% confidence interval, I have t-test, as well as I have p-value, standard deviation of coefficient, and so on and so forth. So now if you look at this job class, so now I'm comparing job class with individuals in the job class. I'm looking at those that are working as an information technologies officer. What is their odd ratio? The odd ratio is 17.27 at 95% confidence interval of 14.35. So explaining this table, if you are not a technical individual, most of the time it will be very difficult or tedious for somebody to interpret and really explain. So our packages, before I carry on, I just want to say a big thank you to the R community and R studio for bringing a powerful packages that will help a researchers or non-technical individual to explain the different model. So below is the explanation of the above table. As you can see, the explanation is of just using one single command. All this information for. So assuming now you are writing a academic manuscript and others research articles, you can easily write a single line of code and generate all these outputs and put it into your articles or manuscripts. So you can see from the explanation on the screen that we repeated a linear model estimated using OLS to predict the weight with job class. As you can see the formula in the bracket, the model explains a statistically significant and weak proportion of variance. The R square is 0.04. So this R square is, we are looking at the correlations, how the variables are correlated to each other. If you can recall, the correlation value is usually started with 0 to 1. So we have our 0.04, that is a weak correlation. But anytime our variable exceeds to these figures, that is to say we have a strong positive correlations. Assuming here is 0.05, that is, we can say we have a positive correlation. So this is the explanation of the model. If you look at the effect of job class on information technologies officer, is statistically significant, and we have a positive correlations with a confidence interval of 17.27 at 95% confidence interval with a lower to upper class boundary. As you can see, the p-value is 0.05. So from this is to say that we are going to reject our null hypothesis to accept our alternative hypothesis. That is to say that individual working in ICT department earns significantly more than individual work in the industry. So, how cool is this? This is a very simple program that will assist you in writing your manuscript as well as articles if you want to do it in the R Studio or R program. Below is the linear plot using a linear regression model. So you can see the plot is illustrated. It gives a clear indications that individual working at industry are less compared to the individual working in ICT department. So this is a nice observation. Below is the multiple linear regression. Remember from my hypothesis, I said that I'm going to look at also multiple variables, that is age, race, educations, and marital status. So below is the table illustrated. This is one of the package GT summary. I use GT summary to illustrate these figures. It's, as you can see from the job class, as I say it earlier, the reference category is the people individual working in industry, while we are comparing it to individual working in ICT department. So you can see the odd ratio here, as well as 95% confidence interval. So we have, in terms of educations, that is, we are looking at this, you can see all the variables indicate a significant factors. If we are looking at the odd ratio among those that has advanced degree, so the odd ratio is almost 63% at 95% confidence interval. So without wasting time, again, if you are not familiar, if you are not a technical individual in explaining the tables above, you can apply a single line command in R Studio. You can get a well-defined output of your analysis. So as you can see, this is the output from the analysis from the R program generated. This is a very easy and it's not too complicated. You can write your manuscript within a shortest possible time. As you can see, this is a graphical representation of those variables, different variables as I illustrated. The last one is the chart comparing the education versus job class. As you can see from this chart here, the left hand side is representing education of individual working in industry, while the other segment is representing the educational level of individual working in ICT department. So from the left hand side, you can see 71% of the individual work with the less qualifications, while on the other hand, you can see 76% of the individual work in the health in 76% of the individual work at ICT department, almost they have advanced degree. So this is an R programming language. Before I proceed, I am a data science, studying my data science at Rome Business School, Nigeria. If anyone of individual has interest in data science, I recommend you to go and join the program. The program is very easy, it's very flexible, you can learn it at your own time. So as I told you, this is a output generated from the R program. Let me take you to the code editing environment so you can see it and understand how the logic is taking place. So this is my R Studio console. Let me maximize the environment so you can see it clearly. This is the R Studio environment using R Markdown documents to produce my output as you see it in the previous. So the first segment is I started with title, that is data analytics and visualization in app. as well as I have my heading, as you can see from the output. Uh, Below is the chunk that I define my hypothesis, as you can see. So this is a code that I use in developing my diagram model. So you can see you can use R program to write your manuscript within a shortest possible time. With this, I would like to say a big thank you to the R community and R studio for bringing these powerful tools to help us in carrying our day-to-day analysis.